Good afternoon.
Good afternoon, sir.
Yes. Hope I am audible. My screen is visible.
Yes, sir. Yes.
Yeah. Before we get into the today's class, probably let us look into the IA test performance and any doubts. Hope you all have received the marks.
No, sir.
Okay, there are 5 students who have submitted late, so probably they would have not got the IA marks. I will read out the names. Apart from that, everybody should have got. Let me check. Abhinav Gupta, Arbaz Khan, Dabamal Chatterjee, Rakesh, Ravi Shankar. These are the 5 candidates who have submitted late as per the GCR. So except these 5, others should have got the marks by now. And this one was absent. Okay. So before we discuss about the marks, let me give the solution, what was expected and what has been given by you. And 99% of you have given the same answers and attempted the similar questions. There was no much difference. So, and we all attempted in the same way, except a couple of you. All have done in the same process. So let me look at the first question. Describe the concept of a program relocation with the help of a neat diagram. Also discuss how the problem of program relocation is solved in SIC-XE. So concept of program relocation is clear. All of you have written that when you change the program, given the program for execution, memory is not even in control. So based on the availability of the memory will be transferred and diagram is given. So that's fine. Next, also discuss how the problem of program relocation is solved in SIC-XE. For this, the solution is your modification record. It is expected that the structure of a modification record is written, a program example with maybe a format for instructions, and a usage of a modification record in object program is expected. So these are the things what is expected for the question as solution, as most of the things could not write the structure and some of you could not write the object code I have mentioned in the remarks, and accordingly marks were removed because I could not give full marks. Maybe 3-4 students have got full marks for this, but not all of you. So that is expected from this particular question. And second, none of you have handwritten this, but let me give the answer. Distinguish between a literal operand and a immediate operand. So literal operand, as the name says, is done with the equal operator, whereas immediate operand with the hash. So here we have to tell what is the literal operand. On the other hand, what is the immediate operand separately, and how literal operands are mentioned, that is using equal operator. On the other hand, how immediate operands are done using hash. Example for both of them. And at the end, literals, you can talk about a LTORG, how they are processed, and immediate operand, how they are processed. So the 4 points what you have to mention for each of them, so that you will get a 4 marks for this. Then next one is explain how forward references are handled in the design of a multi-pass assembler. So in multi-pass assembler, if you see, or even one-pass assembler, the forward references which are not handled in one pass or subsequent process are used in the system or the symbol table with a linked list. So linked list will be used as a solution, or this is one way of handling forward references, so that as and when we encounter a unknown label or symbol, we used to keep that symbol in the symbol table, and attachment to that a linked list is given. Once that address is known, accordingly that link will help us to find out which place the symbol is having an unknown value, and that value will be used. So that is how we used to handle the multi-pass assembler with the forward references. So linked list is a solution, and those 3-4 diagrams will be the solution or answer for this. That's how we have to give the solution. Next important is program blocks. See, program blocks are the concept which we have used in terms of having a multiple sections in a given program. We have to talk basically about the logical rearrangement of the program into various blocks internally. That means only in the beginning maybe in pass 1 they look different, but once they go to pass 2 they're all one and the same. And the related USC, the assembler directive, and a program sample or snippet, and followed by those 3 diagrams. There are 3 diagrams we have used as a C data, CBLKS and stuff like that, and 3 diagrams how the logical rearrangement happens internally, and followed by a small program or maybe example of a program block. So this is how we have to write, and there was a small table as well where first program block, what is the address, second program block, what is the address, third program block, and assembly of program blocks is very important, where we have taken location counter independently in pass 1, assigned a similar number for every program block separately, but when it comes to pass 2 all are visualized as a single program. That is the concept of a assembly of a program block. This is what is expected as a solution, and most of them have not written the assembly. I had to mention that in the solution, and some of you have not written the diagram as well, so accordingly marks were removed or reduced for this question as well. Next question is, discuss the significance of dynamic linking. The dynamic linking is a concept where as and when the program is submitted, during that time the program is taken from the secondary memory to the main memory or from OS or through the OS, and there are 3-4 diagrams for that which we have discussed, and that diagram and discussion is solution for this. Next, discuss the significance of bit mask. See, I told you very clearly, depending upon the type of question you should be answering with the solution. I think some 50% of you have written bit mask in the first question, that is a program relocation. So that was not expected there. That was very clear to inform you that as and when the question appears in the module 2 or module 3, you have to give the solution. And here also questions have been given as per the assembler and linker loader concept, but I don't know, bit mask was given. So first 2-3 questions have written bit mask is not required. Since everybody has copied, I didn't write any comment for that, but bit mask is not the solution for the question 1. So that should not be considered there. Bit mask is only a concept of a linker and loader, just to facilitate that the loader can be able to efficiently manage the program without having a much code for each of the modification bit, because each modification record rather will require a separate line. To avoid that, we used to provide a bit mask or a modification bit. So that was just a facility given to while creating a object program, that is a part of your dynamic loader or linking process. Okay, so that's how we should be, but none of you have answered this in 4, but some of you have used bit mask in the question number 1. Then coming to the 5th question, MASM as a real-time assembler. So what is a MASM and how a real-time assembler can be detailed? So some of the features of MASM need to be discussed here. So none of you have attempted this. Second, again, a note on the MS-DOS linker, same concept. It is also a real-time linker loader, which is going to be available, or which is available rather today, and we could have written some key points about that as well, in line with the MASM. Next, the design of SICXC Bootstrap loader. Everybody has taken the same program. So program 2 parts are there. First part to how these characters are taken, how they have been left shifted and added into one single character, and second part is how to take a character. So these 2 parts are there. A couple of you did not write 2 parts, so probably you didn't get much marks. Those who have written both the parts, most of you have written for that, will get a full mark. So both the parts are required. So you should write the part A, part 2, one for the character clubbing, that is taking 2 different characters, left shifting first one and merging with the previous character, second character. And next one is the how to get the character itself. So these 2 are important. That's why it is 8-mark question for Bootstrap loader. And next, coming to the part B, describe the feature of an assembler that facilitates independent assembly, linking and loading of programs. I need some discussion here because none of you have written solution for this. I think probably first time I am seeing a batch who has not written this answer properly, because this question I have been asking in every batch, and in fact I have asked for once in a VTU exam as well. Many have written, but this batch none of you have written this. I just wanted to have a debate on this. What was the understanding of you for this question? So okay, I may have some quick answers from any of you. What did you understand from this question? Some answers, please. Okay, if you don't want to say, I will do my duty. Fine. So if you look at the question, feature of an assembler that facilitates independent assembly, linking, and loading of programs. So you have got confused with this concept with a independent features of a assembler. That is wrong. So this very clearly asked that describe the feature, only feature of an assembler that facilitates independent assembly, linking, and loading of programs. So I have mentioned that as a solution for all of you. That is a control section. We have to discuss about the control section, that CSEC, EXTDF, EXTRAF, those examples, and that is a solution expected as this. That means this is an indirect question for the explain control sections. Many years we have asked describe control sections, like we have asked illustrate the concept of a program blocks. We could have asked directly describe concept of a control section. But nowadays, for last 3-4 years at least, this question has been reframed or rephrased to ask in a different way. So describe the feature of an assembler that facilitates independent assembly, linking, and loading of the programs. The solution here is control sections, because if you remember, while discussing control sections, we discussed that the feature of a control section is mainly to have a separate or independent assembly of each of the module, each of the subprogram rather, wherever possible to link them separately and load them into the system. If that is a requirement, we have to go with the control section. That's how it is clearly differentiated between a program block and a control section. Program block is a internal rearrangement within the same program, whereas the control section totally different. Each of the subprogram is different. Each of the control section rather is a independent existence. Thereby, since each of the subprogram exists independently, they have to be assembled separately, they have to be linked separately, and obviously they need to be loaded separately. That is a concept what we have to write for question number 7. So all of you got 0 marks for that, because I didn't find any answer, at least from one. Next, the last question is, everybody has just copied whatever the case study that was given to you, which is not a good one. So we know that assembler and loader are two independent pieces of system software with independent functionality. The functionality is what I have given in the case study, so that if you have forgotten, you can remember that. But the question here is, assuming you are a designer of this particular software, but I want you to develop or design both assembler loader into one single piece of software rather than two independent. So far it is assembler is separate, loader is separate. Now I want you to combine as a designer assembler and loader together. And if that is the case, what are all the challenges you faced during that particular process? What are the plus and minus of that particular system software? That was the question asked. That's what it is, a bit innovation involved in this, or maybe thinking process required for you to tell us, in order to make a single piece of software combining the features of assembler and loader, how you should be thinking and what is expected by you, or what you expect rather to be part of that particular system software was the question. Again, no answers from any of you, so most of you have got 0. So that is the concept of 8th question. So this is the solution expected from question paper 2. So probably such questions will be there. We should be very careful. That shows very clearly that you are all not attending classes with mind present. You are all attending only body present, or only online classes. You are taking it for granted. So probably you are paying today for that. So none of you could get more than 25, which is going to be a very not a good sign from my end, at least. Okay, fine. So let us continue with our class now. Yes. So we have discussed about the higher test performance and solution for the various problems. And we are at the last topic of the macro processor. We have seen about what a macro processor is, what were the functions of a macro processor in terms of macro definition, macro call, and macro expansion. We've also seen about the algorithm and data structures of a macro processor. We also looked at the independent features of a macro processor, maybe in terms of a keyword macro expansion, maybe having a unique labels, or maybe a keyword parameters having like similar to default arguments and stuff like that. Now we are in the last portion of this macro processor, which is a macro design options. The first one is macro recursive expansion. So how to have a recursive macro expansion in a macro processor, if at all we want to design. So far what we have designed was just a macro expansion with a nested macros. It is not recursive. Okay, it was just a nested macro. Now we talk about a recursive macro, a macro calling it again and again itself. Then we have a general purpose macro processor. That means irrespective of the language what I have, maybe C or C++ or whatever it is, can I have a general purpose macro processor such that I can look into that. That is the concept of a general purpose macro processor. As we have a general purpose microprocessor, there might be another thinking, is it possible to embed microprocessor as part of each language? So C will have its own microprocessor, C++ will have its own microprocessor, Python will have its own microprocessor, Java will have its own microprocessor. Is that possible? So these are the various ways how to look at the macroprocessor design. So first one is a recursive macro expansion. Second one is a general purpose macro processors, and third one is the macro processors within the language translators. Language translators means your languages, I mean you see C++, Java, high level languages which compile or interpret your high level program and translate them into mission level language. That is the idea behind the macro processors within the language translators. Let us go one by one. So first one, recursive macro expansion. So recursive macro expansion, as the name says, if you look at here, we have a macro definition here, sum. This is the macro definition. Name of this macro is sum. Is a macro definition starting with a macro, and ampersand A and B are the formal parameters, and we have a amend. This is how we have a macro definition. This is what it is, a macro definition. This is the macro signature. If you look at this, we have defined something. While defining, we are calling the same macro within the body. For example, I have a sum. While defining sum, I'm calling sum itself. So this is an example. I'm calling a sum. Actually, it should be, one second. I've given some other name. Let me call. We'll give add. I've defined it as add. I will call add. Fine. Okay. Now, while having a definition for a sum, we have defined another macro which is defined elsewhere, but I'm calling here. So this is how a similar to your nested macro only. Fine. So now we have defined a add, which is a macro here, and I have defined something else here. So while defining one macro, I have called another macro as part of a definition. If that is the case, one macro definition contains the call for another macro. So another example possible, we have one macro, and that macro will have a name of the same macro as a concept. That is an example of a recursive macro expansion possible. So we are invocating one macro within the body of another macro is also can be considered as a recursive macro expansion, which is similar to our nested macros here. So then solution will be similar as we have taken with respect to the design, I mean what you call data structures. During our data structures, we have discussed that argument table is something which is very, very important as part of the data structures. We have seen definition table, we have seen argument table, and we have seen what else? Definition table. So name table, definition table, argument table. Name table will have only names and the links for the beginning and end of the macro definition, and definition table will have the complete body of the macro, and third argument table will have the actual parameters that have been provided at the time of a macro call. But when I have one macro call executing or getting expanded, I will be having that particular macro calls data or parameters as part of the argument table. By chance, if I call one more macro while the current macro is still under processing, then when I get the new macro definition, new macro call, the previous macro data will be lost. So to avoid that, what we have done, we can implement the argument table as a stack. When it is required, when you're dealing with a nested macro, a macro being called within another macro, or the same macro is being called within the macro. In both the cases, we have issue, that is when one particular macro is getting executed or expanded, immediately another macro is also invoked. In that case, the data of a previous or the first getting executed or expanded macro will be lost. To avoid that, we should be saving the data of a previous call or any previous call, so that the subsequent macro expansion will not be disturbing the existing or the present or the current macro expansion or a macro execution. If that is the case, we need to go for a data structure by name stack, because whatever we are getting in the first should be there till the last, or whatever you are getting in the last should be the one which is going to be removed or popped from the list. If that is the case, LIFO or type of data structure which is a stack is required as a basic data structure. That's what we have seen while discussing about the data structure. Same holds good now here as well. So we have a one particular argument table for the call sum 10, 20. If you look at there, sum is main one. Within sum, I'm calling a add. So when I expand this, when sum is used, I am also calling internally, before sum is executed, some add, some number or some definition or some or other macro by name ADD. Then while I am executing this 10 and 20, I am also having a call for another one called as a ADD 30, 40. In normal scenario, this 10 and 20 will be replaced by 30, 40, because every time when a new macro call is seen in the system, the previous data will be lost. So earlier 10 and 20 are there, they get replaced by 30, 40. But in reality, I should not lose 10 and 20, because 10 and 20 are still part of my previous call or a current call. But when I get a new call, unfortunately, the existing data structure arc table cannot manage this. The solution for this is having a stack. So solution for such type of issues is to have a stack. When you have a nested macro or when you have a recursive type of macros, in both the cases, it is better to go for a stack-like data structure, such that we can retain or preserve the first call or first expansion for a macro, along with the subsequent expansions or subsequent calls for the macro, such that every data of a actual parameters of a macro call will be preserved and used until the entire macro gets expanded or executed. So that's what it is. And we can implement the stack using any of the concepts. You can use stack implementation using an array, using a linked list or anything. But the basic data structure that is required is a stack. So that is the idea behind the recursive macro expansion. Any doubts here?
No, sir.
Fine, thank you. Okay, when you use the stack, what will happen? So initial call is 10, 20. First we have called 10, 20. So 10, 20 will be pushed here. And next we have called for ADD. It is not a sub here. Please make a note. It is a ADD. We have changed everywhere it as ADD. So for ADD, 30, 40. Like that, you can keep on calling. You can see here the 10 and 20 are still retained. They are not lost. Otherwise, in the previous case, they were replaced by the new macro call. So to avoid that, we are using a stack, and this stack will preserve the old data as well. This is how it is being done. So the best way is, whenever you want to implement this type of recursive macro expansion, it is better to go for a C or C++, because they by default have a recursion being supported. If you go to Java, maybe your pointers are not available, recursion may not be possible. So better to implement this type of structures design using a C or C++. So that's how it is, because by default, by nature, by virtue, they support recursion as part of their programming concept. So that is going to be very easy to implement. So this is about the recursive macro expansion. Next, let us see the general purpose macroprocessors. There is no much detail here. As the name says, is it possible to have a general purpose macroprocessor? So what you have to see here is look at the concept. What is the concept? I'm going to have a general purpose macroprocessor. What do you mean by general purpose macroprocessor? Let us look at the specific macroprocessor before coming to general purpose. Let me take a C language. So when I develop a macroprocessor for C language, then I will be working in line with the expectations of a C compiler only. When I develop a macroprocessor for SIC, I will take only SIC architecture into consideration, and I develop macroprocessor such that only SIC macroprocessor or macroprocessing requirements are handled by that. That is very, very easy and straightforward. So when you talk about developing or designing a macroprocessor in relation to a specific architecture or in relation to a specific language translator is very easy, because we know that very straight, and for that straight type of language translator we can develop easily. But the question is, I don't know whether I'm using C or C++ or Java or Python. I'm asked to design a general purpose macro. Probably this might be your innovative question, maybe case study for next IA test. What are the challenges or pros and cons you will be facing when you are asked to develop a general purpose macro processor? So what is general purpose macro processor here? No doubt, normally macro processors are attached to a particular language, maybe assembler language or high level language. When you know that we are going to develop a macro processor for a specific assembly level language or high level language, it is very easy. Easy in the sense, we know that what is the target. But here we are talking about developing a general purpose macro processor such that it should be able to process C, it should be able to process C++, it should be able to process Python, it should be able to process Java, or it should be able to process SIC, like that. So I'm just giving an example. So that means more than one language can be handled by this particular macro processor. Is it possible to have one? If it is possible, what changes we need to have? Because when you say general purpose, then you should be very clear. It is like having a bus going on the road, a train going on the track. Fine, both are meant for a particular trajectory. If at all you want to have a bus going on the track or a train going on the normal road, then it is going to be a general purpose. So a bus can go on both road as well as a rail track, where a rail can go on a bus track as well as a rail track. Then it is going to be very, very challenging. It has its own plus and minus. In the similar concept, we have a general purpose macro processor. If you want a particular macro processor to handle two different languages, because each language is unique in its own perspective, then is it possible to have a common macro processor such that both those languages can be using this particular general purpose macro processor? Maybe it is possible in C or C++, because C and C++ share most of the common language constructs. Whereas if you take any other language, maybe say C to Java or C++ to Java or C to Python or C++ to Python, it is very, very difficult because each of those languages are totally different. But as a design perspective, it is possible. We should be able to design if need be. Then we will take C, C++ only. If somebody asks you to design and develop a macro processor for C or C++, how are we going to take it up? So what plus you will see and what minus you will see. So what are the advantages? What are the disadvantages? What are the challenges we are going to face? All those stuff is what we are going to see. First, let us look at the advantages. So if you are going to create a general purpose macro processor, you need not worry much about which architecture or which, because you're developing system software, no doubt. Basically, if you take some common features, okay, I am going to develop a macro processor for this. It should be like this. This is the number of registers. This should be, you are only setting a target. You are not studying architecture here, but you are telling that this is what I am assuming. I assume that my register is having a 16 registers I mean, my architecture is having a 16 registers. It can have a 1 GB of data, or it is the processor like this. This is the facility it has. This is the addressing mode. So you are going to create or assume something in as a standard, and for that standard, you are developing a macro processor. So whichever language follows that standard can be using this microprocessor, or whichever language is built using that particular architecture can make use of this microprocessor. So you are creating a general purpose. You're not, it's like a all fit type of solution. We are not catering to one, but we are going to cater into many. So those many have to decide who where to go and what type of solution we are going to procure. So that is the concept of a general purpose macro processor. So first advantage is you need not worry about which architecture you are going to use and which language you are going. That is now neutral now. So you are creating something, assuming something. So you are the boss. You need not worry too much about a specific architecture. Of course, you need to consider an architecture, but that architecture is a assumption category or advisory category rather than a real-time or a specific architecture that is available in the market. That is the first advantage. Second advantage, since we are having a one common macro processor which can fit into multiple language translators, so purchase of that particular language translator will be economical. Advantage is because same thing I can use for this C language, C++, Java, Python, means my Python, C++, Java cost will come reduced because one common software development is being used for the multiple languages. Obviously, my cost of software is going to be reduced, or it is going to be economical. That is the idea behind, or that is advantage rather with respect to having a general purpose macro processor. What are the disadvantages? So general purpose macro processor is only general in criteria. So, but when I have some specific things in my programming language, this may not be able to process. If that is the case, again, I have to understand that particular language, go through it and do it. It is going to be a big headache for me. It is overhead. Because as advantage, what you have seen, I need not worry about the underlying architecture or underlying language, then develop something. Maybe or may not be, you may get a type of language what we are looking for based on this particular architecture available in the market. If it is available, it's well and good. If it is not available, then you have to again tune your design such that it is going to make use of certain specifics which you have not thought of. You have generally made 80%. 20% specifics are there because each language is different and it has maybe 20 to 30% uniqueness. How are you going to handle that 30% uniqueness? If at all you want to make a general purpose microprocessor, the 30% things of a particular specific language cannot be handled by microprocessor. That becomes a disadvantage. So what to do now? Then we have to embed those also. Okay, for this particular language, if it is used, then this is what I need to do. So then your language translator, your microprocessor will become more complex. So that is the disadvantage, meaning that understanding some of the key or maybe a novel data handling of a particular language need to be incorporated in the general purpose, which may be an overhead for this. And second, a general purpose microprocessor, as we know, each language is independent and unique, cannot suit for everything. So you may develop a language processor, hardly two language. You may develop a macro processor which may fit into hardly 2 or maximum 3 type of macro processor. Language translators. The best example can be only C++. No other language is having so much of commonality compared to C++. If that is the case, C and C++ only we can think at this point of time where a common macro processor is possible so that we can have it, or a general macro processor is possible so that C and C++ can use it. Otherwise, as a thinking point of view, it's fine, but it has its own plus and minus. See, design is different. You are going to make real time or not is secondary, but is it possible to design? That's what we have seen in assembler also. One pass assembler, multi-pass assembler. You may not require them every time. 2-pass assembler is sufficient for 90% of the cases. But for 10% of the cases, yes, it may be required to go for a 1-pass, or it may be required to go for a multi-pass. So that is a design concept. So you have a freedom to decide or discuss whether it is feasible or not feasible. If it is feasible, what is the plus, what is the minus, what is the pro, what is the con, all those things you have a free mindset to decide. That's why all these type of questions are there to kindle your thinking. Okay, I want to develop a general purpose macroprocessor. What all I need to face? What is good for me? What is not good for me? What is advantageous for me? What is not so advantageous for me? What is the plus? What is the cost? All those aspects we have to think. So this is basically to kindle your thinking. Design means kindling our thinking, kindling our analytical way of looking at a given problem. That's what we should be. That's what is discussed under the general purpose macroprocessor. So general purpose macroprocessors are not advised to have, because macroprocessors having their own specific requirement to be dealt with within the language translators. But our requirement is it possible to have a general purpose macroprocessor? The question is yes or no. If it is yes, yes, it is advantageous for those reasons. No, because this, whichever you feel comfortable. If advantages are more for your requirement, go with this. If disadvantages are more with this particular setup, better to not to go with this. So depending upon what is our requirement and what is our take, we can take a call whether to have a general purpose macroprocessor or not. So that is the idea behind, just a concept here. That is the idea behind general purpose macroprocessor. And the last one is macroprocessors within the language translator. This is what we normally see. Every language processor, high level language rather, at least now we have a C, C++, Java, Python. They all have their own macro processors internally. That means your source program will not be directly given to the assembler or compiler unless it is given without any macro process. If it is having any macro processing related idea, then it has to go to the macro processor. Then only it will be given to the assembler or compiler. Later we will get an object program. So macro processor resides between your source program and assembler. In other words, before a program is given to the assembler for further processing, it has to go through the macro processor if at all any macro processing is required. Once macro processing is done, then your assembler or compiler will get into the system. This diagram will describe or depict about with macro processors how our language translators means assemblers, interpreters, compilers, which convert or translate our high level language or assembly level language into their mission equivalent object programs. There may be assembler or an interpreter or a compiler. So if that is the case, how are we going to deal? Obviously, as we have seen disadvantages in the previous case by having a general purpose macroprocessor where it may not fit into every programming language, it is better to have a separate macroprocessor within the each language translator. Maybe SIC have separately, SICXC have separate microprocessor, C have separate microprocessor, Java have separate macroprocessor, Python have separate microprocessor. That's what we can advise in the third design. Second design was having a general. We have seen plus and minus. Now, having said that, is it possible to have a within the language translator a specific macroprocessor? Is it going to be advantageous? Better, because we want to do macro processing for some purpose and we cannot give it to general, because if you give it to general, some specific things of a language will be lost. So it is better to have a macro processor within the given language translator. For example, C, if you take, C should have its own language translator. If you take C++, C++ should have its own language translator. That's what I mean. It's one macro processor. That's the concept what you can think of as far as the macro processors within the language translators are concerned. Without macro processor also possible, because if you don't have any processing of macro, then probably we will be having a macro processor without such type of language translators without such type of macro processors. That is the concept of a macro processors within the language translators. So you can look at this. We have a macro processor which produces a revised source program. So when I give source program to macro processor processes them wherever macros are there. What is the processing here? Expanding the program wherever there is a macro call, all those stuff. After that, the revised program will be given to the assembler or a compiler or an interpreter. Later we'll get an object program. So revised source program is what something that is given to the assembler or compiler. Later, we can also think of having both macro processor assembler so that the creation of intermediate file can be avoided. So both can be clubbed into one particular processor. So that's what we see with C and C++. You give a program to compiler, C or C++. Compiler internally will have a macro processor. This is having a separate macro processor. Now we are talking about a within the language translator or a assembler or a compiler. So this diagram is what we are going to look at now. So compiler or assembler, it internally having a inbuilt macro processor. Both are same, but one is a independent entity, other one is a combined entity. That's what we have to see. So that the source program will be taken one at a time by the macro processor, and a revised program will be directly given within the compiler, and compiler will be able to process. So both are giving the same result, but only thing is who will have the control. Here macro processor will be independent, whereas here macro processor will be within the compiler or a assembler. So concept wise both are same, because internally the structure is different. That is the idea behind the macro processors within the language translators. So what is the advantages now? Instead of giving to macro processor, then taking the revisor program, then sending into assembler, we can have the same program. So there is no additional scanning of the program required. So one time only we can complete. And some common data structures if we have, we can merge them. That is going to be more advantageous, and it is very easy to scan and provide the any buggy related data to the system. So it's only convenience what we are saying, but process is not going to change. It is only advantageous from the resource management side only. On the other hand, as we are combining, maybe we have those type of compilers possible, and those type of compilers which can combine macro processing is only can deal, others may not be in a position to do. So as these are combined with our programming languages, they cannot be dealt with others. So that means your general purpose is lost. So everything has its own plus and minus, but we better go for this only, because we need a macro processor built in with respect to a programming language, not in general. So it is advantageous to go for a macro processors within the language translators rather than going for a general purpose, simply because each compiler or each language translator is unique and independent, thereby having their own compatible macro processor is always advised. That is the idea behind having a various design options of a macro processor. So if you look at, we have discussed about 3 macro processor design options. One is a recursive macro expansion, wherein to deal with nested macros or recursive macros, we need to engage with the argument table, otherwise we'll be losing them. To avoid that, a stack-like data structure is a feasible one. Second, we have seen language translators within the language translators having a macro processors, because they also going to reduce some of the time and make sure some resources are reutilized without wasting. That is also possible. And some other general type of macro processors who do not take into consideration any architecture or any language, but generally on some assumed type of architecture or language they are built upon. But since their assumption, they may not be meeting the real-time processors or real-time language translators 100%. So they have their own plus and minus. So depending upon the requirement, depending upon the case with which we are working, so probably we need to look at the design option. So be ready for having any innovative questions on this as well, because designs are always innovative in nature. So this concludes our microprocessor, and the last topic is implementation examples. As usual, you will be taking an assignment on this. So can any of you remind me the questions what you have taken for the third assignment? Because I told you some questions will take from module 3, some will be taken from module 4. If you can help me, what are the questions we have taken for module 3? I believe 3 questions were given. Then remaining 2 questions I will give now. That becomes a one particular assignment. You can submit that maybe by next week, 16th. Okay, so take those 2 assignment questions that will be added to the already given questions. I have given 3 questions probably on linkers and loaders, and I also told you that that assignment is not complete until I give 2 more questions. And 2 more questions are this: explain MASM macro processor and discuss about the ANSYS macro processor.